Hello students. Once again, I apologize for the poor audio quality. Still do not have my headset to do the recording. But anyway, these should be the notes for Tuesday's class, and these should be the final notes coming into the next test. I anticipate a Unit 2B test over the inverses and the asymptotes and all that kind of stuff on Thursday. So if you have not begun to prepare yourself, please start getting ready for that. Our objective for Tuesday will be the student will learn to determine possible asymptotes from reading the equations of the functions. Again, I anticipate these being the notes for Tuesday. That would be October the 8th. Copy down your objective and the date. Press pause anytime you need more time, and then hit play when you're ready to move on. Okay, now as we discovered yesterday, there's three different types of asymptotes we are on the lookout for. One of them is the horizontal asymptotes. These are actually the most difficult to identify in the equations because there are different ways that they may show up. Now, in order to have a horizontal asymptote, the function must be what we call a rational function. And if you remember back to junior high, the term rational means that it is of a fraction. So here we are defining a function, f of x, in terms of a numerator that has something to do with x, divided by a denominator that has something to do with x. Okay, so n of x is some polynomial in the numerator, d of x is some polynomial in the denominator. Now, what we're going to do is we are going to compare the leading terms of the numerator and the denominator. And if when the polynomials are organized correctly, the leading terms will be the term that has the highest exponent in both the numerator and the denominator. Our polynomials should be written in what is called decreasing order, meaning the highest exponent is on the left of the polynomial, then the next highest exponent, then the next, and then the next, until you get all the way down to the constant. Now, when you look at the leading terms, one of the following conditions will be the truth.
I love you.
Okay, if the exponents of the leading terms are equal to each other, then there is going to be a horizontal asymptote to the graph. On the other hand, the exponent of the leading term of the numerator could be less than the exponent of the leading term of the denominator. This will also cause a horizontal asymptote. The difference between the first two options is that if the exponents are equal, the horizontal asymptote might be anywhere along the y-axis, the horizontal line anywhere along the y-axis. If the second of these is true, where the lead term, the exponent of the lead term is less than the exponent of the lead term of the denominator, then the horizontal asymptote is actually going to be exactly on the x-axis. The third and final situation that might occur is that the exponent of the leading term of the numerator could be more than the exponent of the leading term of the denominator. When this happens, there will not be a horizontal asymptote. So there's three different conditions that we have to watch out for when we're looking at a rational expression when trying to decide if there's going to be a horizontal asymptote or not. Vertical asymptotes are a whole lot easier to watch out for. The same conditions must apply. We have to have a function that is a rational function, so we have the same definition again, f of x equals the numerator of x over a denominator of x. Okay, so same conditions as with horizontal, so if you've already copied those down, you might want to put a star next to them where you wrote them down for horizontal, and then make a note to look back at the star for the vertical asymptotes. And the condition will be that vertical asymptotes only occur when or if there is a value for x that will cause the denominator of x to equal 0. And that brings us to the third and final type of asymptotes, which are oblique or slant, as they are sometimes called. The same conditions must apply. So again, you can refer back to those conditions that you put a star next to on your horizontal asymptotes. You have to have a rational function, and your numerator is some type of polynomial, and your denominator is some type of polynomial. And the condition will be this. Vertical asymptotes only occur when or if the exponent of the lead term of the numerator is exactly one more than the exponent of the lead term of the denominator. That's a very specific condition, but it also makes it one that is very easy to identify. Okay, now we looked at three equations yesterday, and we saw the graphs and could identify asymptotes by looking at the graphs. Now let's look at their equations. Okay, so we looked at the reciprocal of x yesterday. Okay, so let's ask ourselves now, does it have a horizontal asymptote? Now remember that the horizontal asymptote occurs by comparing the highest power of the numerator to the highest power of the denominator. Well, the highest power of the numerator is 0. We have an x to the 0 term, which is a constant. And the denominator, we have an x to the first term. So the denominator's power is higher than the numerator's. So what does that mean in terms of a horizontal asymptote? It means that, yes, there is a horizontal asymptote. Remember that the only condition where there will not be a horizontal asymptote is if the highest power of the numerator is higher than the highest power of the denominator. Now, what about a vertical asymptote? Now, remember, what is a vertical asymptote looking for? It is looking for a value that's such that the denominator can actually equal 0. Okay, so it is possible for the denominator to equal 0, obviously, when x equals 0. Okay, so that means that, yes, there will be a vertical asymptote to this graph. And lastly, how about an oblique or slant asymptote? Well, remember what the oblique is looking for. Oblique wants the exponent, highest exponent of the numerator to be 1 unit higher than the highest exponent of the denominator. As you can see from the equation, we have the exact opposite of that, so there will not be an oblique asymptote. Okay, here's another equation from yesterday. Let's roll through this again. Does this equation have a horizontal asymptote? Sorry for all the background noise. I've got a cat chasing around a little ball with a bell inside of it and a dog that's scratching his collar. So I'm getting all kinds of jingling in the room. Anyway, back to the problem. Horizontal asymptote. Remember that a horizontal asymptote will happen if the highest powers are both equal or if the denominator's power is higher than the numerator's. Well, you can see from looking at the problem that the highest power of the numerator is 2, highest power of the denominator is only 1, so this will not meet the requirements for a horizontal asymptote, so there will not be one. How about a vertical asymptote? Is there a value that could possibly make the denominator equal 0? Absolutely. X could equal 0. That will cause a vertical asymptote. And how about an oblique asymptote? Remember, the qualification for the oblique asymptote is very specific. The highest power of the numerator needs to be 1 unit higher than the highest power of the denominator. That's exactly what we are seeing here. We've got x squared in the numerator, x to the first in the denominator. The numerator is 1 unit higher, so it will have an oblique asymptote. And then the final example that we looked at from yesterday, will it have a horizontal asymptote? Clearly, we have the same leading coefficient, or same leading variable power. They are both x to the first. So yes, we will have a horizontal asymptote. How about a vertical? Is there a value that can cause the denominator to equal 0? Yes, once again, just like the first two, if x is 0, that's going to cause the denominator to be 0, so we will have a vertical asymptote. Thirdly, will it have an oblique asymptote? Well, the oblique asymptote requires the numerator's highest power to be 1 more than the denominator's highest power. We do not have that, so there will not be an oblique asymptote for this equation. I have two more examples that we will address tomorrow in class just to refresh our memories when we come in on the horizontal and vertical and oblique asymptotes requirements. Go ahead and please copy this equation down as well as the one that will be on the next screen. And while you've got your notes there, go ahead and see if you can answer, will it have a horizontal or vertical or oblique asymptotes for this equation? And then also for this equation. Same three questions. See if you can't get those answered. We'll see you in class on Tuesday for these notes, and we'll start off by reviewing these. As I said, this will conclude the material going towards the next test. Wednesday will be a review day. Thursday will be a test day. Make sure you are preparing yourself correctly for those tests. Some of you have not fared very well on the first 2 unit tests. We need to do a better job of walking through the door prepared. We'll see you in class.